All right, no more Freudian stuff about my childhood and how hard at it I was, I promise. But, again, you're probably like me here. It's like I look at four paths from point A to point B, and I want to use them all because that sounds like it's more efficient. We're going to do a walkthrough here with 3 switches and 4 hosts, and in this network, STP is not in use. And as I make a note here, one more note about switching loops. They're sometimes called bridging loops because, of course, it's a legacy term, and we always say legacy because we don't like to say old. Like, oh, I'm feeling kind of legacy today, that kind of thing. See, it does sound a lot better. Here we have 2 hosts at the top of our network, if you will, host A and host B. 2 more at the bottom, host C and host D. And our 3 switches, all their upper ports are fast Ethernet 0.1, all lower ports fast Ethernet 0.2. Host A is sending a frame to host C. Now with this particular setup, the 3 switches are all going to get a copy of that frame, and they're all going to see it, and they're going to say, hey, what do they do first? They look at the source MAC address of the incoming frame and say, do I have an entry for that in my MAC address table? See, you already knew that stuff. You didn't even need me to tell you. And the thing is, what are they going to do now? They're going to make a note that host A is off Ethernet 0.1, fast Ethernet 0.1 that is, and then if they've just been turned on, which is another assumption we're going to make through the miracle of technology, they will flood the frame that is destined for host C because we are assuming they do not have an entry for said host. So you can see that we already end up having trouble with this particular topology because each switch is going to send a copy of that frame out their fast Ethernet 0.2 ports. So what happens? Each switch ends up getting a copy sent by a neighboring switch, and the problem is the source MAC address for that is still going to be host A. So now all 3 switches believe host A is actually found off fast Ethernet 0.2. And just that quickly, we end up with a mess and we end up with a routing loop, because what's going to happen is that that's just going to keep happening. We're going to have these frames that continually get flooded out, which, tends to build up, and it's sucking up our bandwidth, and the switches are having to work harder handling it all. And it's the kind of thing that starts slowly, because that's what broadcast storms do, a term we used in the last video. A broadcast storm, doesn't happen all at one time. You start hearing people saying, well, the network seems a little slow this morning. Well, let's face it, someone's always saying that. So, you might not pay a world of attention to somebody, especially if they complain a lot. It's just like, oh, it's just another complaint. But then you realize over a little bit of time that, yeah, things seem to be slowing down a little bit. Well, STP helps to prevent those broadcast storms because STP helps to prevent a situation like this. And again, that broadcast storm just builds up slowly but surely because you get more and more flooded traffic forwarded by those switches and sent by the switches. And finally, the switches are so busy handling all these extra frames that we end up with what we call a broadcast storm. Now, in real-world networking, we don't bump into switching loops often. We run into fewer broadcast storms certainly than we used to because STP does a wonderful job of preventing switching loops before they happen, which is the best time to get rid of them. It really all begins with an exchange of what we call Bridge Protocol Data Units, BPDUs, a term you're going to hear a lot here in the next couple of videos. And we're going to go ahead and dive into this BPDUs in the root bridge election and cover a little bit of theory here. Because what happens is STP will determine a root bridge for every VLAN in our network. And yes, our root bridges are switches because, again, we're going to a legacy term. You can call them root switches if you want to. I tend to do that from time to time. But on your exam, I expect the term root bridge to be used. Now, root bridge election theory can be a little overwhelming the first time you see it. So if this is your first time, be kind to yourself. You'll get it. But after we cover a little bit of terminology, we're going to see the election in a 2-switch network and also in a walkthrough using 3 switches. Maybe not necessarily in that order, but we'll do a walkthrough and see what each switch is seeing, and then we'll jump on the live equipment and do an election in at least a 2-switch network. And we'll see STP in action along the way, including some things that just might surprise you. So hang in there with yourself. If this is the first time you've seen it, you will knock every STP question out on exam day. Let me move that over just a bit there. When a baby arrives in this world, my friends, that baby acts like it's the center of the universe. In some ways it is, and in some ways it isn't. Well, what happens? The baby yells, baby cries, baby screams. Baby expects to have every desire attended to immediately. Now, most of us grow out of this. A couple of us don't, but we're going to leave that alone for right now. The reason I bring this up is in a similar fashion, when a switch is first powered on, it believes it's the center of your universe, if you will, your switching universe, because it believes it's the root bridge for every VLAN on your network. Well, that would be fine, except we're probably going to have more than one switch. Might have 2, might have 20, might have 50. So we got to have some kind of selection process here to decide who actually is the root bridge for every VLAN on your network. And that selection in this way, or in this particular situation, is an election. That's what we have. And that election process is carried out via the exchange of those BPDUs. Now, switches are continually sending BPDUs or forwarding BPDUs or originating BPDUs in some cases, but they are the only network devices that do so. Servers, routers, hubs, repeaters, they have absolutely nothing to do with BPDUs. This is a bridge protocol data unit. It's only going out between our switches. Now, there are 2 major BPDU types. And the second one here is a little out of the scope of the exam. Some books may not even mention them. I want to mention them to you because I want you to know they exist. But we have configuration BPDUs and TCN BPDUs. Now, the configuration BPDUs, thankfully, are more commonly referred to as hello BPDUs or simply BPDUs. That's how I will refer to them, as hello BPDUs or just simply hellos. TCP BPDUs, not easy to say. They are out of the scope of the CCNA exam. We're interested in concentrating on the root bridge election. Now, only the root bridge itself, once this election has taken place, will actually originate the hellos. The non-roots will receive it, and they'll look at it, and they'll forward it, but the non-roots will not actually create hello BPDUs. The root bridge is also the switch that decides what the STP timers are even going to be. We will see that in action after we have an election. Now, here's the value that comes into play with our election. It's called a BID, a bridge ID. Each switch has one, and it's a combination of a 2-byte priority value and the switch's 6-byte MAC address. The priority value comes first. So if you have a switch with a default priority of 32.768 and a MAC address of 112233445566, the resulting bit is 32.768 : and then the MAC address. So that tells us that if the priority is left at the default on all switches, the MAC address ends up being the deciding factor, and the switch with the lowest MAC address wins. Now, in any network, you're going to have switches that are more powerful than others in terms of processing power and speed. In general, you should ensure that your primary and your secondary root bridges are your more powerful switches. You don't necessarily want to leave those roles to chance. Now, again, if you're working with a smaller network, a good example, some school system networks that I worked with when I first broke into networking. And that was actually my first network admin job at a high school. That was pretty interesting stuff. But the thing was, I got to work with a lot of great hardware, and I never gave any thought to who the root bridge was. We had a couple of switches at each school. And the thing was, in that particular instance, it didn't really matter. All the switches were exactly the same. But the thing is, sometimes you want to spread that load out a little bit, or sometimes you want to point to a switch and say, okay, this is going to be my route. You don't want to leave it up to, oh, by the way, whoever has the lowest MAC address, that's going to be my route for all my VLANs. Maybe you don't want to do that, and I'll show you exactly how you can change the root bridge elections after we walk through an example of a root bridge election using only the defaults, and we're going to take a closer look at the STP port states between blocking and forwarding, and that's all coming up next.